Excellent. Thank you. Good morning, good afternoon, good evening, everyone. Welcome to this panel for this discussion. It's on why edge cloud computing is essential in the transformation to Industry 4.0. It's going to be a three-person panel here. I'll be the moderator. I'm Patrick Heffernan from Technology Business Research. And I'm joined at the moment by Mikkel Berger, but we're also going to be joined by Rob High as soon as he's able to join us. He's been having a busy day off during this conference with some other panels. We'll get him on here shortly, but maybe we'll get Mikkel. We'll get your introduction first, then we'll talk about me, and then we'll talk about what industry or what edge cloud is going to do for Industry 4.0.
Okay, so thank you, Patrick. So I'm Michel Burger. I'm the CTO of mimik, and I have a long background on technology, starting at Non-Proprietary Networks, actually a Canadian company, where I was doing networking. But then I moved to Microsoft. I was a CTO of the communication sector. And then I moved to Vodafone, where I was a chief architect for R&D and distinguished engineer. Then I moved to APG, where I was the chief architect for a large account and IoT. And then I joined mimik.
And I have almost the exact kind of opposite background for two people on a technology panel, because I do not have an engineering degree, nor do I have much of a technology background. I was actually a diplomat for about 14 years before I joined Deloitte, one of the big four firms, and spent my time looking at the competitive landscape, which has really evolved into the ecosystem landscape. So our firm, Technology Business Research, looks at the business side of the technology field. And so we're constantly being forced to understand how do companies adjust their business models to emerging technologies, and how do companies adjust their business models in an ecosystem where the partnerships are changing all the time. You're from mimik. Rob High is from IBM. We'll have him on shortly to talk about that part. Maybe if we could just start with sort of some of the basics around edge and cloud, because coming at it from a business perspective, these things are, if not the same, they're awfully closely related. So could you maybe walk through where you see differences between the two and why they're important, not only from a technology sense, from a business sense as well?
So I would start from the technology perspective, but technology-wise, so we all know about the cloud. And what's happening today is you have two movements which are moving to the edge because people are realizing that latency, cost, and other factors are becoming more and more important for the solutions. So you have all the hyperscaler doing a cloud out approach, where basically they're trying to put data center, nano data center, micro data center as close as possible of where the consumption of the service which run on the resources. So Amazon, Google, and others, and Microsoft have all a solution which is kind of like a cloud out solution. And why it's cloud out? Because it's basically saying, let us replicate what we've done in the cloud, which is about computing resource, storage, and things, and then push all of this as close as possible. And then you have more like an edge-in type approach, and that's what mimik took as the approach to do edge cloud. So the edge-in approach is to say like all of these devices which are in the hand of users or in manufacturing plant and or in on the road and things like this have more and more computing power, which means that they basically could act as element of a cloud where they talk to each other and then talk to the cloud itself. But by doing this, what we realize is that the main difference is when you look at the cloud, every resource are very generic, like it's a blade, it's a storage, and things like this. At the edge, the resources are much more typed. It's a phone of a user, it's a robot, it's something like this. And because of the strongly typed nature of the device, you have to treat the cluster you create, you have to treat the system you handle in a different fashion than just by dealing with generic blades.
That's an excellent way to start, and I think you've already brought a couple of questions to my mind that we'll get to in a minute. But let's welcome Rob Rob, hi. Thanks for joining. I understand it's been a crazy day for you, but welcome. So we did very quick introductions. Maybe you could give us a quick introduction to get us rolling here. The rest of the panel.
Okay, yeah, very good. And forgive me for being late. I was somehow confused about the connection. But anyway, yes, I'm Rob Hai. I'm the CTO for IBM's edge computing business. I have been working with Michelle very closely on the collaboration and integration of both the mimik technology and what we call the IBM Edge Application Manager. And I just caught the tail end of what Michelle was saying and talking a little bit about the situation that we have to deal with.
Excellent. Maybe we can build on what Michelle said about sort of the latency issues, and if you could maybe connect that to the business case. Like, why is it so important? What is it about latency that makes edge so much different than cloud? It's something that honestly I hear from the business perspective of, make a business case for this.
Yeah, and I have to, we have to be clear. It's actually four things that drive the business value for edge computing, and what latency is one of them. We'll get to the other three in a minute, but let me just answer your question first. Latency really matters to certain real-time problems. If I'm trying to evaluate all the potential maintenance problems that might exist on a train, and that train is passing past my cameras at 60 miles an hour, or whatever is that, 90 kilometers an hour. And I'm looking for maybe 120 different kinds of problems. The amount of time that I have available to me to examine that train, each car as it passes by, and look for all those 120 different problems before that train has arrived at the next station where perhaps those problems need to be resolved is extremely small. If I had to send an image up to the cloud to be processed for every frame of that that's being processed for that car, for every car that's in the train, and get all of that processed, we would never get through all of that processing in time for those decisions to be made. So the ability to make fast and excellent decisions is becoming increasingly important to how businesses operate, and the things that we need to be able to do to be more efficient, more productive. But as I said, latency is just one. The other is the cost of transmission. In the scenario I just described, imagine how many frames of video data we would have to send to the cloud. And by the way, in this scenario, we have 20 cameras arrayed around the train as it passes through at 60 miles an hour. And we've got to take all of those camera images and send them up to the cloud. That's terabytes of data that you have to transmit, and that gets expensive. Now, in that situation, you can say, well, I'm going to turn that on or turn that off for a period of time, and the only data I'm going to transmit is the data that I need for that period of time. Of course, it's still expensive, but not as expensive as if I'm running it the entire day. If I've got a security camera where I'm just looking for people that might come by and try to break in the back door of my factory, I've got hours and hours of video data that nothing is happening, right? In fact, it may be months or years before somebody attempts to break in that back door. And so I've got all this video data that I've transmitted at an enormous cost that has nothing important in it that I care about. Right. The third one is just the cost of protecting our personal and private information. Both as a consumer, as an employee, but even as a business, right? If I've got cameras arrayed across my factory and I'm using it to do quality inspection or some other process optimization, it's collecting up all kinds of data about my business and the state of my business. And if that data were to leak out, that could be a fairly substantial cost. And of course, the last thing is just resilience in being able to maintain my factory operations or my retail operations when the network, if it does go down, I don't want to be shutting down my business.
Those last two are really interesting for me because security and the privacy element is usually something that is dealt with. It might be dealt with by the tech side of the house, but it's very much the risk side of the house. And then the cost as well. That's where we're talking about, the CFO coming in. So do you see the conversations around edge and cloud changing, and particularly around edge changing because of who's in the room to have those discussions?
Yeah, I certainly do. And Michelle, I'm sure you have seen this too. Cloud computing was mostly a concern of the CIO. Where is the best and most efficient way in place for me to do my compute? I have a responsibility for doing this compute. I can either do it in my data center, or I can do it in the cloud and get some cost efficiencies. Edge computing is about lines of business. As you said, it's really about delivering on business innovation and business value. And so it very much involves line of business leaders. And so, yes, of course, the CFO, the CMO, the COO, and sometimes even the CEO are edge computing is about how we make their business more efficient.
Yeah, we saw like many companies where they got this sticker shock of cloud expense. So because at the beginning everything is rosy and everybody's saying, oh, yeah, cloud makes everything easy, and suddenly the bill comes. And many startups we have dealt with have seen that sticker shock to a point where when we arrived with the edge type approach, there was a factor of 10 of reduction of the cost, which means that yes, of course, the CFO was super interested. The IT guys was in a sense less interested, because remember that for him he look at consumerization of the IT resource. So cloud is a very interesting model, and edge implies like more distribution and things like this. So it's more, you have more resistance from IT, but from the business line, like Rob is saying, and from the CFO and the marketing people, actually they will appreciate more edge than actually the IT guy because of the business requirement.
I'm fascinated. How do the marketing people get involved? Or what are the use cases where folks in marketing care about edge?
Well, because the marketing guys, they look at use case or the user journey. And because they look at user journey, they want the user journey to be as seamless as possible. And if then latency get into the solution or like cost of bandwidth and things like this, that will hinder the user journey, and they therefore will say, I need to have an alternate solution. And therefore, having an edge solution which actually doesn't even impact the legacy IT system is an interesting prospect from a marketing perspective.
And digital transformation. What's interesting about one of the side effects of this COVID pandemic that we've all suffered through over the last year and a half is how it has accelerated digital transformation. Right? You can't go to a restaurant today without being exposed to a QR code to get your menu. Right? Well, that's a change in how I interrelate with that business. I order online even when I'm there at the store, at the restaurant. I'm still ordering online, or at least I'm getting the menu online. In many cases, you are actually doing the order online. But it's also changing the user experience with that business.
And also when you look at again the user journey piece, as Rob mentioned at the beginning, like privacy for me is a key factor. See, knowing that the raw data will never leave the phone. It simplifies a lot of things, because like GDPR and rules like this, which are very much geared towards backend system, you change completely the equation when actually the raw data will never go in the cloud. What will go in the cloud will be aggregated data, almost anonymized data already. So which means that it's a different dynamic. And again, view from that perspective, the marketing guy who is trying to get a solution quickly will have less constraint to do it than if it had to be going to the backend and therefore having to follow rules like GDPR or HIPAA or things like that.
It's been fascinating, because I did not think we were going to talk about the marketing guys on this particular panel, but I want to do a really quick poll. Out of the three of us, who wishes we could go back to just using the paper, menus, or who likes the QR code? I like a normal menu myself. So.
Oh, I don't know. I don't mind the QR code because I don't like touching other people's papers. But
Well, I was in a restaurant this yesterday night and with my kids, and there was a QR code and there was a paper solution. And then they tried to set you up that on the QR code you had more item than actually on the menu, but that was not true, and therefore we all went to the paper solution.
So that's a perfect segue into the discussion about digital transformation, because Rob, you brought up that term. It means a lot of things to a lot of people. It also means nothing to a lot of people because it's so vague and so broad. But in this particular case, when we're talking about, and let's maybe talk about Mimik and IBM together, sort of an ecosystem play within this whole idea of digital transformation. How do the two companies work together to bring digital transformation, but also how do you see the larger ecosystem as part of this? Where is this evolving to?
So if I could start this off, Michelle, I want to draw back to a comment that Michelle just made about personal and private information as well. Because when you change the dynamic about how information is being handled, where things like, personal information could be, and I really, it's not just about our individual information, it's about even the business information. Not only does it reduce sort of the burden of some of these processes like GDPR, it actually unlocks a lot of innovation. I can now suddenly do things that I couldn't do before because I don't have to worry about the data being exposed, but even more so, I can take the inferences that are drawn from that data and use it in new ways. And so one aspect of digital transformation actually is unlocking innovation around business value, unlocking new ideas, be creative and expand. And, and so when you take the idea and you unlock, these additional possibilities, then something like what IBM and Mimik are doing together as a platform to enable that transformation becomes really powerful, right? We can now start to imagine the idea of, putting industrial workloads on a mobile device or on on legacy devices that perhaps, have not really been participating in the modern digital transformation era. So I think what we've done together is a very powerful thing to, take advantage of the unlocking the digital transformation brings to the table to now enable that through our platform.
Sure. And see the point of the edge, and the people will say that increase the cost of distribution, but actually with IBM technology, we alleviate that. And the interesting piece is the way it's handled is handled in a way that it's very typical to the edge. See, I remember having discussion with Rob on how you use Kubernetes, and you should do Kubernetes at the edge, and we both agreed that actually it doesn't work this way because, again, the resource at the edge are strongly tied, and then because of that you arrive to new dynamic like a choreography of device instead of strong orchestration. Why? Because you want to make decision quickly, and you want to create like eventually optimal system instead of constantly optimal, because the speed is a factor. And that, because it happened at the edge, you actually don't touch the legacy system. And by not touching the legacy system, you actually perform a digital transformation without having this huge project where you're trying to bring two legacy systems together, which generally takes enormous amount of time and generally never works very well. Well, now you do it at the edge, which means that now you have simplified the way you handle the data, but you also have simplified the way you handle processes and how the different nodes, which are the different devices, actually connect to each other and communicate with each other.
This pendulum between distributed versus centralized computing is a theory of computing. we've seen this pendulum go back and forth. I mean, this for me is my third iteration in this pendulum, right? Client server, mobile computing, now edge computing. And what's interesting is if you look back, there was the reason that pendulum continues to have momentum behind it is that there's a need to, increase and improve user experiences. There's a need to, address the costs of latency and protecting personal and private information. There's a need to, that need is there, which is why people continue to gravitate back to trying to make it work. But the problem is always been, how do you control that? And how do you control that, efficiently, effectively, in an environment that is both diverse and dynamic and inherently insecure just by virtue of the fact that there's attack surfaces that we don't normally experience in the IT data center. And I think that's the magic of what we've done here together is that we've kind of made the cost of centrally managing a very diverse and dynamic distributed system, not only reducing that cost down to minimal levels, right? But more importantly, done so in a way that is highly secure and very well protected, overcoming some of the limitations while, going back to the term unlocking, the potential that this distributed edge computing environment serves. And yes, of course, there's a tie back to cloud because that's become sort of the golden standard for software development practices and the use of containers as an essential component for containerized or for componentized software engineering. But, as Michelle said, it's not always going to run on an OpenShift or Kubernetes. Sometimes it's enough just to have an OCI compliant container runtime. And that's all you need. As long as you have the ability to host a container, get the right container to the right place at the right time, manage that in the presence of diversity and dynamism, and do so securely, and not burden, the institution with a tremendous workforce of administrators to do all that.
And it's interesting when you mentioned this pendulum notion where the beauty of it is when the pendulum moves back and forth, the situation changed completely. So which means that everybody is telling me, oh, but you're back to putting everything on the device. Well, no, yes and no. We put more things on the device because the device have more computing power, but now it's in a form of microservice, API, and with a dynamic distribution at our application edge manager from IBM, which means that we take the pendulum of client server versus like a thick client, but actually it's still a very thin client plus a bunch of microservices that run at the edge. And the interesting piece is, and that's where you see the technology helping a lot. Like at Mimik, we had this constraint that everything had to be in a JavaScript environment. And now with WebAssembly, we realize that now we can actually run microservice in any kind of language, which means that we really, really now provide an environment for a backend developer to do things at the edge in a similar model than what he or she is doing on the backend, but with the help of the way it's distributed, the way it's managed, and the way it's processed, it becomes very seamless. So it's more like, maybe we should start to talk about more like fluid computing, where basically it's the microservice moves seamlessly from the backend to the edge, or from the edge to the backend, depending on the situation, the condition, and the environment.
Yep.
So that raises two questions for me. I got a bunch of questions, and I'm going to start with just what you just said. Does Mimik and do IBM find that you've got the people out there that can do everything that you just said, and not only for Mimik and for IBM, but also for your clients? Or are you spending a lot of your time with a lot of education, a lot of explaining, a lot of training, a lot of bringing clients up to being able to really get the best benefit out of everything that you're bringing to them, this platform that you mentioned?
Michelle, why don't you lead off? I have an answer for that, but I'll let you start out.
So the interesting piece is actually for me the biggest burden is the transformation from monolithic to microservice, because in a sense, remember that you have a lot of enterprise architects who have lived their life in a client-server mode where the server was a very monolithic, like a multi-session, multi-tenant type machine, and was one unit. Now it's all about microservice. So the good news is the microservice trend on the back end is moving very quickly, and like when you see Netflix and others doing this, and because of the fact that with the IBM application head management and mimik edgeEngine, which allow you to run microservice at the edge, the model remains the same for this type of developers, which means that once you have passed the burden of monolithic versus microservice, after that, the centralized to edge is actually a way easier task.
That's right. That's exactly right. So do we spend a lot of time with clients? Yes, but not around the issues of infrastructure or technology. It's really around the use cases. We spend a lot of our time with customers, helping them imagine the use case opportunities and really exploring where to push that boundary. I'll say a lot of the use cases today are centered around visual recognition tasks, but I think that'll change. But yeah, I mean, the only other time that we really kind of get burdened with a technology discussion is with those few customers who today have not embraced cloud computing and therefore don't know what a container is and have to be taught how to containerize their workloads, which is rare, but it happens. The rest of what we've done in terms of infrastructure, managing the application deployment, managing the allocation of resources to support that, that's kind of built in to the system now. And so, that only takes a few minutes to get people up to speed on what to do there.
Yeah, I spend a lot of time with consultants and with IT services companies, and they tell us again and again, it's a truism for us that the technology is never the problem. It's the people who are the problem. I mean, the reaction to that swing back and forth that you mentioned, Rob, and then sort of the challenges. And I'm wondering, and use cases always come up as a way of overcoming that, of beginning change management is to begin with a use case. Is there one that is a good one to share, Michelle or Rob, that you can sort of start off with?
Well, again, as Rob mentioned, this image recognition, where basically what you do is you train the model on the back end because you need tons of data and tons of processing for that. But once you have the model, you basically push the model using the application edge manager from IBM into a microservice at the edge. And now the algorithm at the edge, which is also something you can push dynamically, will consume this model. So that's kind of like the first level where you do really recognition at the edge. But then, and that's where you see the mindset changing, where people are saying, but you also should do stage recognition. So you should first do maybe a raw recognition and then go to a gateway to do a more enhanced recognition before you go to a cloud where you do maybe a third level recognition. But the ability to do stage recognition, which optimize the amount of data you send, the response time, because as soon as you do edge recognition, you can make decision at that point, even if it's on a less refined recognition, but you can still start to make decision in order to trigger more comprehensive process on the other level, which is a gateway or the cloud. And that's for me the very, very compelling way to say, like, from a user, from a technology, and from a business perspective, you can see where edge will shine on this type of solution.
Yeah, and I agree. The visual recognition scenarios are probably the most common today. One we're doing, I mentioned earlier, with the railroad company who's looking at, all of the maintenance issues that could occur on a train as it passes by. And as Michelle said, I mean, there's a series of things that have to happen. First of all, you have to look at the image and say, okay, yeah, that's the cylinder in the closed position, or that's a brake pad that is, at a certain level of depth, or, that's the first, you're just kind of drawing, perception kinds of inferences. I perceive this, I perceive that. And then you draw conclusions from that. Okay, well, if the shaft is in a certain position and, this latch is in a different position, that is a problem. Or if it's in the other position, it's not a problem. So you draw higher order conclusions from that. And then you go, well, but this is only the first time we've seen that, and we know that sometimes happens, in a certain grade. These things will shift around sometimes if they hit a certain bump at a certain grade, a certain angle. But if it happens 3 times, then we know we've got a maintenance issue. So now I'm going to trigger a maintenance routine on that. And sometimes, the staging of these different inferences may happen across a distributed network in the way that Michelle described. Some of it happening on the camera, some happening in local service, some happening in the cloud. In other cases, it's all happening right there. There's logical phases, but yet they're all happening together. We're doing a piece of work with Premier and Marine AI to build an autonomous ship that will sail from Plymouth, England to the US entirely on its own, fully autonomous, self-driving, self-navigating. You might think, well, that's no big problem. You just get it going in the right direction, and eventually it shows up on the other side of the ocean. But the fact is that along the way, you have to recognize what other ships are passing in your direction. You have to recognize, debris that may have fallen off of ship and is floating around in the water. Of course, you have to look out for the land masses that suddenly pop up in your screen, right? Lots of things like this. And then again, secondary processing. Now that I recognize that's a ship, well, what are the rules of navigation that would suggest I should go this way or that way, or how do I optimize that decision going one way or the other? And then the third example of this is work that we're doing with manufacturer on detecting for weld quality. Again, a visual recognition, in this case infrared, but still looking at the quality of the weld at the moment that it's being welded so that we can tell whether that's a good weld or a bad weld without having to go back and break it open in order to determine that.
And also there is a piece where, like at Mimik, we're working with a few customers where we're talking about field maintenance, where the field maintenance person has a device which actually will do the next stage recognition. So which means that now it's not the device, the gateway, or the local server, and then the cloud. Is actually 2 devices which can talk to each other and dynamically discover each other. And now the device of the field maintenance person will receive the feed and will start to do another level of recognition the device cannot do in order to do more intelligent repair. So that's where you start to see the physical world meeting the logical world, because the business process, which in this case will have implied like a cloud system which will have made all of this decision, is now a choreography between 2 devices and processes on these 2 devices.
It's not just the physical world and the digital world, it's the financial world too, because those field service workers, that's an expense. And nobody likes to send the guy out twice or 3 times when it could have been done once. And Rob, I love the story about the ship. I'm just worried that if it comes to the Port of Savannah right now, it's not going to be able to dock anyway, so it's going to have to circle around out there. We got a bunch of questions that came in, and I'll get to them, but before we do in these last 10 minutes or so, I'd love to know, this is something I ask a lot of people in this entire space, is sort of throw your mind out 5 years and look back on what's changed. And what would you describe as the changes that have happened over the last 5 years, if you're 5 years in our future right now? And Michelle, maybe if you go first, just give us, what does success look like? What does change look like over the next 5 years?
Well, for me, success will be when all the cloud native became edge native people, where basically they understand, from a technology perspective, that all of this fluidity of the microservice are doable. And second is the business people, where the business people themselves are becoming edge native. So they're not trying to do the old new scenario, but they're really trying to do new scenario because of the nature of edge and because of this more stickiness of the digital with the reality at the edge, and the ability to then mimic processes at the edge, which they could not happen with a strong cloud mindset.
Yeah, so I mean, one of the most profound trends that I think will inform where things go over the next 5 years for me has been what we've seen happen in the world of AI over the last 5 years and what we expect from that going forward. As we already indicated, you know, visual recognition tasks are probably the most common examples of edge computing, but it's not the only one. And what I think is really important about what's happening today in the AI world is that I think finally the marketplace has come to understand that AI is not about artificial intelligence. It's not about, you know, replacing the human mind. It's about augmenting the human mind. It's about, you know, drawing not just insights from the data, but creating inspiration from the data.
Yep.
You know, activating the human imagination to consider new ideas, to think about new opportunities, to, you know, recognize things that might otherwise elude us, even if we were just look at the insights, so that we can make better decisions. And, you know, I think there's been a long period here where people kind of reacted to AI as though, on the one hand, oh my God, this thing's going to take over all of our jobs and replace the human endeavor, to then the pendulum kind of went the other way to, well, AI is just machine learning. Anything that requires some, you know, trend analysis, we're going to refer to as AI. I think we're now all starting to mature. And I think over the next 5 years, that maturation will begin to realize in forms that not only take advantage and exploit edge computing because of the compute power that's there. And by the way, that's the other trend, is just the rapid increase in compute capacity that we're seeing. Of course, along with that is the rapid growth of data, which exacerbates the problem, which is our inability to kind of, you know, consume and assimilate massive quantities of data. But the opportunity then to use AI is to consume that data and draw from that inferences and present those inferences in a way that activates our human, you know, our human thinking, our human thought processes.
And I think that in the next 5 years, we will have seen many successful digital transformation triggered by the edge, in the sense that, and for me, that will be a success, like with a new cloud neutral approach of IBM plus Mimic tech platform. I will expect that there will be many successful digital transformation where basically you had this legacy system which were too frightening to touch, but actually all the edge was a way to trigger and implement successfully a digital transformation without having to touch this legacy system. That's what you could expect in the next 5 years also.
And that has a massive implication around M&A and what happens when you make an acquisition that's got a legacy system. So, and to be able to leapfrog it the way you described. So I want to bring in a couple questions. One of them is couldn't be more perfectly timed. Can edge devices handle the brute power needed for AI applications?
Yes.
Or maybe that's a yes. No. Is that a yes? No? Yes.
Absolutely. Yeah, I mean, you know, if you even look today at, you know, there's lots of examples of, you know, $180, $200 intelligent cameras that have a GPU built into them. You know, forgive me for flashing Apple up here, but, you know, there's co-processors in these mobile devices that are quite capable. You know, I mean, you already see it. They do facial recognition. They do all kinds of AI related things. So the answer is absolutely yes.
Definitely, yes. It's and not just in my view, not even just the recognition part, even partial training based on local data will start to happen at the end.
Yeah, yep, that's right. Federated training.
So another question that came in is hybrid edge computing to innovate for a company like banks? So basically, banks rely heavily on legacy infrastructure. So is edge computing really helpful for them in terms of innovation? I'm going to guess again, right?
Well, what's interesting is that, you know, we use the term edge computing now to kind of imply, you know, something modern that's only just now happening. But in banking, for the last 50 years, 40 years at least, we've had teller machines, we had teller, compute and branch banking controllers, we've had ATMs, with compute, and that by any other definition would be what we now call edge computing. Probably the only difference is that it was all based on proprietary technologies for the last several decades. But, banks today already run edge computers in their branches, and it just has evolved in its form over time.
And also it's what we can see, and we have actually already demonstrated this to a bank, which is application to application communication, where basically, and this at the edge, which means that now a bank can create ecosystem with other companies to exchange data at the edge in a secure fashion, which means that they don't have to do the integration on the back end, which will be very difficult because this legacy system generally have the level of protocol they use is very strange for many people, which means that doing it at the edge and transferring the data at the edge will enable and is starting to enable a solution of data exchange, which basically allow a bank to start to do a more offering or a more precise view of what their customers are.
Yeah, better user experiences. Absolutely.
Yeah.
And better user experience is one of the things that drove those initial digital transformation comments or engagements at the beginning. So we'll continue to drive them, I'm sure. We only have a couple minutes left. This question, I think we tackled at the very beginning. What are the main benefits of migrating to edge? Rob, you mentioned the latency, you mentioned security, you mentioned cost. There was a fourth I can't remember, but are there other things as well?
Privacy and personal information. Yeah. And there's others, certainly the enhancements around user experience, that come from that, which is a derivative of lower latency and the local processing you do to create user experiences. The concept of influencing humans in the style that I described in terms of augmented intelligence. At the end of the day, humans are psychological, meaning, we are motivated by our psychology. We're motivated by the subtleties and our personality and the way that we activate and trigger, our energy and all those sorts of things. And so in some ways you have to have a very personal experience to be able to do that. And so for augmented intelligence to really work well, it's got to tailor that experience to us individually.
Yeah, and for me, this notion of hyper-connected world enabled by, and I will flash my device, which is not an iPhone, but will be, is because, remember, these devices are supercomputers, so which means that you could think that a lot of things then will be enabled, like this app-to-app communication or the ability to retain the data in this device and just send aggregated data or anonymized data to the cloud is something crucial for the future of the internet.
It's been fantastic. I know we're out of time, gentlemen. I took a bunch of notes. I'm not even sure why. I was supposed to be hosting a panel. I ended up scribbling a bunch of things down. Questions I still have for you guys. But thank you so much, gentlemen. And any last comments before we close?
Just want to thank you, Patrick, for hosting us, and to the Mimik team for your partnership, and thank you to the MTL folks for giving us this opportunity.
Yeah, thank you, everybody, and especially Rob to be such a support on Mimik technology. I know it was a challenge, but we managed to do it. It's great.